Good day, class. I welcome you to today's lecture. You are welcome to week 2. So we are starting with lesson 1 of area of plane shapes. What is area of plane shape? Area of a plane shape is the amount of space it occupies. Here are the diagrams that shows different types of shapes that we have. And you have done this earlier. We have rectangle, square, triangle, parallelogram, trapezium, and circle. I only put this just to remind you that you have done this when you were in JS1. So because we are starting with the other parts of area of a plane shape now. Alright, let's quickly flash back to what we have done before. We have to calculate the area of the following shapes. So the first one is rectangle. The formula for finding rectangle is what? Length times breadth. And that is 4 centimeter times 8 centimeter, and it gives us 32 centimeter square. I may not be able to dwell much on all this one since you have done that before. So let's look at the second question. The second question is to find the area of the square. In square, all the lengths are equal, either breadth or length, whatsoever they call it. They all have the same sides. So if they ask you to find the area of square, since the length is equal to breadth, that means length times length is equal to what? Length square. Or since the length is equal to breadth, you can say the breadth times breadth, and that gives you what? That gives b square. So now the area of this square will be 4 meter by times 4 meter, and that is 16 meter square. Let's look at the C part where it has to find the area of the triangle. The formula of finding the area of triangle is what? Half base times height. So if you substitute in your value, you have 8.908 centimeter square. Okay, here we have circle. What is the area of a circle? Well, when radius is given, the formula you have to use is pi r square, and pi is a constant of what? 22/7 or 3.14. Sometimes they might give you the value of pi, sometimes even though the question will not mention pi for you, you should know that the constant value for pi is what? 22/7 or 3.14. So now you are asked to find the area of a circle. You look at the parameter as well. Where radius is given, the formula is different from when diameter is given. So the area of a circle for radius is pi r square. As in when radius is given, the formula you use is pi r square. But if radius is not given, the formula that you will use if it's diameter, it will be pi d square over 4, and that is how we solved for it here. So the first one, 10.5 centimeter, was given as what? As the radius. So we only substitute in our value as that of pi r square into that of pi r square, and that gives us 346.185 centimeter square. So the second part of the circle, the diameter, you can see that the line touches both ends of what? Both edge of the circumference, and that is what? The diameter. It run through the center. So we have 22/7 times 14/2 all squared centimeter. So that gives us 615.44 divided by 4, and that is 153.86 centimeter square. Alright, area of a parallelogram. For parallelogram, the two opposite sides are equal. So where you have 6.2 centimeters is also 6.2 centimeter here. As the height is 12.1 centimeter, it is also 12.1 centimeter here. But the formula for finding area of parallelogram is base times height. In fact, you can use the formula of parallelogram to find that of rectangle, to calculate for that of what? Triangle as well, because triangle is half of parallelogram. If you divide the parallelogram, if you draw a diagonal line across like this or this, it gives you half of the parallelogram, and that is your triangle. So here the formula for area of parallelogram is base times height. When you substitute in your formula, the base 6.2 centimeter times 12.1 centimeter. That gives us 75.02 centimeter square. I believe you are getting that, and that is also reminding you of what you have done before. All right, area of trapezium. The formula for finding area of trapezium is 1 over 2 in bracket a plus b. This side, the upper diagonal side, the upper sides, and this sides, they are the one we refer to as a b, the two parallel sides, this and this. So sorry for that. And that is what 9 centimeter plus 6 centimeter give us 15 centimeter times the height, which is 6 centimeter. So that gives 45 centimeter square. Let's look at this composite shape. When we say a composite shape, it means what? When two different types of shapes are combined together. We have the semicircle and we have the rectangle. The semicircle is having diameter of what? 4 centimeter. If you curve this away from this rectangle, it gives you a semicircle of diameter 4 centimeter. Alright, the formula for finding area is pi r square, and a semicircle is half of area. Can you see from the formula, half of the area is semicircle? So in that case, the formula will now be what? 1 over 2 of pi r square. So substitute in your value. Your diameter here is 4 centimeter. So that means the radius is what? The radius is 2 centimeter. So that is what you will substitute into this value. So this half will cancel this one. This half cancel the 2. So you have only 2 centimeter square left times 22 over 7. So the value is 6.29 centimeter square. We also have a rectangle of length and breadth 11 centimeter and 3 centimeter. And the formula for finding rectangle is what? Length times breadth. When you substitute in your value, you have what? 33 centimeter square. We are only asked to find the area of the shape. Though when they didn't specify that you should find this, but you should know that since it's a composite shape, you have to find the length, the area separately by bisecting or dissecting, to just make sure you have a certain shape to work for. So now the area of that plane shape that is given is for you to add all the value you have calculated, that is the area of the semicircle plus the area of the rectangle. So if you sum them together, you have 39.29 centimeter square. Another one I'm still considering now is this of example 3. We asked to calculate the area of the red region shaded below. This is the red region, and the red region is a square from my own perspective, and I also have a circle here of radius what? 5 centimeter. So we have been given one of the side of this square to be what? 20 centimeter. Now we are asked to find the area of the red region. How are we going to do that? You need to first find the area of this square, and after that you find the area of the circle. Then you subtract the area of the circle from that of the square, and that should have given you the area of the shaded portion. Alright, let's move on. Area of square is what? Length times length or breadth times breadth, and that is what? 20 centimeters times 20 centimeter, that is 400 centimeter square. Area of the circle is what? Pi r square. So you substitute in your formula. Thank God it was radius given to you, so you substitute for your radius to be 5 centimeter times 5 centimeter, and pi is what? 22 over 7. So when you calculate that, you have 78.57 centimeter square. Now we have already calculated for the area of the square, and that of what? And the area of the circle. So you now say area of the square minus area of circle to give us 321.43 centimeter square. Okay, you can also work it out to cross check that. Alright, that is the end of lesson 1. So this is your assignment. Please try as much as possible, attempt the assignment, and make sure you submit it to the required mail. Thank you. Welcome to lesson 2 of area of a plane shape. So now we want to look at area of plane shapes using trigonometry. Let's look at this shape together. area of a triangle, we all know that area of triangle is what? Half base times height. But here we were given theta on angle B. We have the height, the hypotenuse is here. Okay, let's look at the relationship of the height to the hypotenuse and the angle. You should know that this height is what? Opposite of this theta of angle B. So let's see how we can make this height subject of the formula in such a way that we'll be able to substitute it into we'll be able to represent it with another thing here. Alright, area is what? Half base times height, and that is what? 1/2. The base is A, you can see A here, and this is the height, you can see H. Alright, but our reference angle is this B. Okay, so recall that sine B is what? H over C. That is opposite over hypotenuse. If you make H the subject of the formula, it will be C sine B, which is equation 2 here. Now, when you go back, when you check this H to be equal to C sine B, you can substitute in the value of C sine B into what? Into this equation. Substitute it into this equation. This equation, come back to this equation of 1/2 times AH. So when you substitute it, we have 1/2 AC sine B, and your B is what? Is the theta. So you can have it as what again? 1/2 AC sine beta. Your A and C are the size, and that B is what? Your angle B. Let's see one example we can use. Let's look at this example. Example 1. Find the area of the triangle below. We solved to make H the subject of the formula. Here we want to find H. We were not even given H. In that case, instead of you to be working from using Pythagoras theorem or Pythagoras rule to find the value of your H, just go straight to use your formula of 1/2 times AC sine theta. 1/2 times A times C sine theta. And when you find the sine of 82 on your 4-figure table, or you press your calculator, sine 82, the value is 0.9903. So multiply it by this value, you have 59.42 centimeters square. You can see that this formula is straightforward, because if you want to find your height, you first use Pythagoras rule. After, when you have solved for your Pythagoras rule to find the value of your H, you will then use the formula for what? For triangle, and that is 1/2 times base times height. But instead, just make use of this formula of 1/2 AC sine beta. Area of parallelogram. We also want to apply the trigonometry formula for this. We know that area of parallelogram is base times height, but sometimes the height might not be given, and the moment you have your angle, it is very easy for you to solve. Now let's see the position of H when we relate the angle to this A. Are you with me? The H here is opposite, while this A is what? The hypotenuse. So what is the relationship of this theta to H and A? So sine theta is what? H over A, opposite over the hypotenuse. This A side is my own hypotenuse. You can look at it very well, it's the longest side. So your H value will be what? A sine theta. Is that taken? So substitute in this value into this first equation. So where you see H, it will not be H again, it will be A sine theta. So by the time you put it here, you have area to be equal to AB sine theta. Okay, so let's look at one question for that. Alright, here we have 73 degrees. Have you seen the angle here? Here we have the opposite, and this is what? And this is the hypotenuse. Are you with me? So now we know sine 73 will be what? Opposite over hypotenuse, and the opposite is H over 9 centimeter. So 9 centimeter times sine 73 degree, and that is what? The height, if you check the four-figure table, sine of 73 gives you this. So the height is what? 8.61 centimeter. Is that taken? Alright, so area of parallelogram will then be what? Base times height. The value you've gotten here, use it to multiply this, the base, and that is what? 103.3 centimeter square. But we can still make use of the formula straight away. We have AB sine theta. Substituting the value of your A is what? Is 9. B is what? 12. Sine theta is what? Sine 73. Find the sine of your 73 on the four-figure table. It still give you the same thing as 103.3 centimeter square. Wow. Even though you can see that you only need just one step or two for the use of the trigonometry formula. But look at the first one. You first need to calculate for height. After that, you come back to the formula. Are you with me? So you will see that this is very simple and straightforward. Another example, find the area of the trapezium in the figure below. We want to find the area of the trapezium. So here we have angle 123 degree. You will see 90 degree at this edge. Can you see the 90 degree? So that means 90 degree plus alpha gives us 123. What is the value of this alpha? That means 90 should be subtracted from 123. Are you with me? You need to subtract that 90 from 123, and the remaining value gives you what? Gives you this small angle. So that is what we have here, 23 degree. When you subtract 90 from 123, we have 23 degree.